Okay. Already we have completed our first section, that is 3 chapter. So today we will take just overview about the section number first. Yeah sir.
Yes, sir.
हा आवाज व्यवस्थित येतोय
हा येतोय.
आणि रेकॉर्डिंग पण सुरू आहे ना.
हा सुरू आहे.
Okay. Roll number 2, 3, 26 and 20 present. Okay. So I will take just review. So we will start from the first chapter. Okay. So we will go slowly. So in first section, we have seen that first chapter, that is a introduction part of the CAD-CAM CE. Okay. So in that we have seen that you can see here uh, product cycle and CAD-CAM CE, then advantages, disadvantages, what are the hardwares, then list of the input and output devices, then functions of the graphic software, and a major important role in industry, that is a selection of and good CAD-CAM CE software for a particular manufacturing machine. Okay. So this is the syllabus for the first chapter. In that we have seen that the meaning of the CAD-CAM CA, okay, means what is the important role of the CAD phase, then CAM and CA. In CAD phase, we are going to design or make a geometrical model with a given specification for a particular that manufacturing. Okay. So after that, once you complete this first CAD phase, then we have to go for the second phase. That is nothing but your manufacturing phase. So in that manufacturing phase, we have to make a process plan, make a programming part program for that manufacturing. So all this sequence manufacturing, that part programming, uh, that part done in the second phase, and last phase, that is a just synthesis, nothing but analysis phase, that is our CAE. Okay, that is the most important phase in our industry. So we have to validate that whatever that we have draw, means make made a geometrical model. That model, it is really feasible with given working condition or given boundary condition to that particular loading, to that particular boundary condition, whether it is yes or no. If yes, then you can carry for that actual manufacturing. If no, then you have to some make modification in your initial CAD phase. Okay, then you have to just follow our cycle CAD, CAM, CA. So this is the just meaning of our first chapter, CAD, CAM, CA. So we have seen that the product design concept, how our product is launched in your industry. Okay, so for that we have to go for the initial phase, means recognition of the needs, means we have to just recognize what is the actual need of this product. Okay, so then we have to go for some definition, actual modeling. Okay, like this. Then we have seen that the actual product cycle, how our product will be gone through all these processes. Okay, so this is common for all the products. Okay, then we have seen some advantages of the CAD-CAM CE, how we will achieve the more advantages by using this CAD-CAM CE system as compared to our conventional system. Okay, so we have seen that some disadvantages also. For that purpose, we need some skilled person and trained people for doing the part programming also and for operating that higher level system. Okay, so this is the some example of the some companies which are providing some a product in terms of the CAD-CAM CA for 2D work, 3D work, automation work. Okay, so we have seen the some graphics software functions, how the graphics software will be worked for the given CAD/CAM CA conditions. Okay. There are major parts means design workstation and other input output and secondary storage. So there are some functions. Then we have seen that some image generation process like CRT. Okay. So there are two methods to create the image in CRT. One is a stroke writing and second is raster scan. So again, they are divided into three types, subtypes. According to that subtypes, they will give some advantages. Okay. So in terms of the image generation, picture quality, data content, like this, there are some parameters. From that parameters, we are going to divide these three types. Then we have seen that the input devices in CAD/CAM system. So this is the general things. We know all about this joystick, mouse, trackball, light pen. Light pen is currently no one is using, but in that CAD phase era, basically starting phase of the CAD, that time everyone using this light pen method. Digitizer, then data logging system. Okay. So these are the some input devices we are using in CAD/CAM system. Then output devices we are using in our daily life routine for taking the printout, for taking the flex banner. For that purpose, we are using the plotter, printer. Okay. So these are the example of the output devices of our CAD/CAM system. So next part, that is we have seen that the software configuration. So how our CAD/CAM software will run with the help of the other parameters. So in that important parameter like this database, then application program and graphics package. In that graphics package or graphics terminal, we have to use one kernel system. Okay, for the running that particular software. Okay. So this is a general features we can call as a general flow diagram of the software configuration. Then we have seen that some history of the CAD/CAM CE. So how the CAD/CAM CE was developed later in after 1950, then 1960, 70 to 80. Okay, slowly our CAD system will be improved, was improved. So basically they have invented just IGS format. Then they will just making the new smart computers. Later on, they will develop some reverse engineering capability. Then they have developed a virtual factory. Then 3D printing, rapid prototyping. Like this, they are just moving on for the betterment. So this is the history, and we have seen some objective type question. We have taken quiz also. So this is the overview about our first chapter, that is the introduction to CAD/CAM CA. Okay. So we will move towards next chapter. So we will move towards second chapter. So basically, second chapter is the most important chapter in our CAD/CAM CA chapter subject. That is in that basically two parts is there. So first is computer graphics and geometric modeling. Basically, in that computer graphics, we are going to see only the methods to how to generate geometrical model. And geometric modeling, we are actually seeing how to develop actual model with the help of the three different types of the modeling. Okay, with the surface modeling, solid modeling, and wireframe modeling. Okay, so we have seen that the syllabus means what is mean by geometric transformation. Then its types, near about 5 types. Then homogeneous coordinates, rings transformation, then coordinate transformation, standardization in graphics software, CAD/CAM data exchange, with introduction to geometric modeling and its types. Okay. So basically we have that, and according to the three types, we have seen some advantages and disadvantages of that modeling. Then we have seen that the parameters, curves in that spline, Bezier, nerves. Okay. Then we have seen that some application of the solid modeling and advantages. So we will just take a review. So geometric transformation, in that we have seen that the some translation, rotation, scaling, reflection, and shear. So basically, this is just a general form of the geometric transformation. Here we are going to take place at a single problem at a single operation. Okay. Suppose you can take a single problem. Here I want to do some translation command. So in that type we have to do only one operation. Okay. So in this type we can call as a simple geometric transformation problems. And in that simple geometric problem we have used addition in only translation, and remaining operation we have to use a multiplication command. Okay. So remember, always remember, when you are going to facing a single problem, in that time you have to use a single geometric transformation problem, simple. So in that, translation is using addition command and other transformation using multiplication command. Okay. So just remember that basic difference in homogeneous and this simple geometric transformation. So we have seen that the translation formula. So basically, we can take the example as a point P, which is having x and y coordinate. So I want to translate that point P to P dash. So formula for that geometric transformation translation, P dash is equal to P, that is the original point, plus translation matrix. And translation matrix formula is capital T is equal to Tx and Ty. Tx is nothing but translation in x direction, and Ty is nothing but translation is y direction. Okay. So already we have seen some example. So you can just go through that notes and just recall that all the points. Second is the rotational. Okay. So rotation is nothing but we want to just translate that entity at some angle. Okay. So for particular point or other at origin. Already I have discussed regarding that the when we have to use a simple geometric translation and when we have to use a homogeneous. Suppose already I have told you that at a single problem, single operation, we have to use simple geometric transformation. But in that single problem, single operation, if they want to do operation at a particular point, means they have to rotate a triangle ABC at point C. So rather than origin, they are asking rotation at a particular point C. Then we have to use homogeneous transformation operation. Okay. So just remember that some 3 to 4 notes already I have given to you when we have to use simple and when we have to use a homogeneous. Okay. So basically rotation transformation formula as cos theta sin theta minus sin theta cos theta. Okay. So just remember the actual matrix formula for each and every transformation formula, means translation, rotation, mirror, share, and scale. Okay. So next is scale. So hello. Yes, sir.
Yes, sir.
Everything is audible or any problem?
Audible, sir. Just you have to
Okay, okay.
change sound
Someone
setting.
is just means audio is less.
हाँ हाँ.
Yes, yes. Now,
Yes, sir.
okay, no problem. So this is the third type of the transformation. Here we have to form a scale matrix formula in terms of the Sx and Sy. Sx means scaling factor in x direction, scaling factor in y direction, that is a Sy. Okay. So basically we have seen how to scale the entity in terms of the x and y direction. So there are two types. So uniform means we have to do the scaling in both sides with equal units. Means Sx is equal to 2, then Sy is equal to 2. That is a uniform scaling. If you want to do non-uniform scaling, then you can use Sx value is different than Sy value. So we have seen that some example related to that scaling also. Next is a mirror reflection. Okay, suppose if you want to do the mirror about y-axis, so formula is different. Then x-axis, then about y is equal to x, then y is equal to minus x, then both axes. So in mirror, actually there are 5 formulas regarding the according to the axis and the line. Okay, so just you have to remember that all the 5 formulas for the mirror, and in terms of the homogeneous transformation, you have to just make a formula from this basis. Okay, suppose we have to do the formula mirror matrix formula in the homogeneous. So there is no specific formula. There is just coordinate A, B, C, D. Okay. So suppose in that 3 by 3 mirror matrix, if in that problem, they want to do the mirror about the line X. So in that formula 3 by 3 matrix, we have to put in terms of the ABCD formula, means here about the x-axis mirror formula means 1 0 0 minus 1, that will be values for the ABCD. Okay, like this we have to make a formula for the mirror matrix in the homogeneous transformation. So next we have seen that some example of the mirror, then shear transformation. Okay, so we have seen that the shear in x direction, y direction. Some examples. Then actually homogeneous transformation means we have to do homogeneous means at a single problem we have to do more than two operation at a single time. So for that purpose we have to use homogeneous coordinate transformation system. Okay. So there are some 5 formulas for the homogeneous coordinate system in terms of the 3 by 3 matrix. So translation, rotation, scaling, mirror, shear. Okay. So these are the important and standard formulas for the homogeneous coordinate transformation. So we have seen that some example related to homogeneous. Then windowing and viewing means whatever that interested area from the whole the geometry entity, from that we have to just keep that interested part only. We can zoom it, zoom out, and we can focus on that interested part. This is one of the best tool where at the time of the analysis and at the time of the modeling we have to use. Okay. So next coordinate system. So in that we have to do some transformation means local to global coordinate and global to local. At that time we have to use this type of the coordinate system. Then we have seen that the standardization means with standard and without standards. Without standards means we are not using that kernel code system and device handler. Okay. So in that graphic system, if you are using some kernel core system or any device handler, so that system will become a standard system. Okay. So there is some basic needs of the graphics standard in terms of the picture, object, text portability, and application portability. Okay, that is the basic need to the graphics software to increase the standard. Next, there are some graphic standards. We have seen that the GKS, PHIGS, IGES, STEP. So in that IGES, the latest format, I think all of the software using this IGS format for the exchanging the graphics. We have seen that this system, then important part, that is a CAD/CAM data exchange. How we can exchange the data in between two systems or in between two industries. Okay, so there is two types. There is the first indirect and second is direct. So in indirect format, we have to do some neutral file. We have to do some pre-processing and post-processing in between that file. Okay, so for that, this is one requirement. Just we have to do pre-processing and post-processing on that file. Then we can transfer that one file to the second software in this indirect format. But in direct format, we can transfer that information, that file, to any of the software with directly. There is no need to the do any neutral file, do any pre-processing and post-processing. Okay, so this is the difference between direct and indirect data exchange. Then we have seen some product database format. Okay, its advantages and disadvantages. Then application, why we are using this type of the geometric transformation. What is the actual benefits of this geometric transformation in your industry? Okay, so that will be a most precise point in this chapter. We will get better portability, we will get easiness to draw the model, we need to go for the precise value. So that things we will get from this geometric transformation. Then some application where we can use this geometric transformation. We have seen some objectification. We have taken one quiz also. Okay. So next part is introduction to geometric modeling. So what is mean by geometric modeling? We have to use some techniques from the CAD system, CAM system. Then we have to draw our 3D part, and that 3D part we are going to uh, transfer for the further analysis process. So there are actually three types of the modeling. Wireframe we have seen. It is a basic form of the any geometric modeling where we cannot calculate the area as well as a volume, okay, as well as the surface information also. This is only a fundamental base of the any 3D model. Okay. So advantages, it requires less space. Okay. So disadvantages means we cannot find more information related to that model. Only wireframe means only node and element is there. Okay. There is no actual surface. There is no actual area and volume also. So second type is a surface modeling. In that surface modeling, we can just create a surface by using a sheet metal part. Okay. Where they are required only sheet metal part, only small thickness. You can take example of the a bonnet part of the four-wheeler. So this is the part of the sheet metal. So for that purpose, we can use this surface modeling. In this type, only surface is there. We can call it just we can calculate the surface entity only. This is the types of the surfaces means plane surface, ruled, sphere, tabulated, bezier, B-spline, NURBS. Okay, this is the kind of the surfaces where we can use this type of the surfaces for the actual modeling. As you can see, for plane, ruled, revolution means you can just create one axis. Along that axis, you can create one geometry and you can revolve about the axis 360 degree. You will get actual 3D image. The Bezier curve, cone surface, lofted surface. Then last but not least, very important, that is the solid modeling. From this solid modeling, you can calculate the area of the cross section for that particular drawing, volume. Each and every information you will get from this solid modeling. Okay, so you can calculate area, volume, because of in that format you we will get all the information regarding that material. Okay, nodes, elements, surfaces, body, because this is a solid body, so you can calculate each and everything from this drawing. So from this figure, from this distinguish, you will understood better way how solid model is better from the surface and wireframe. You can see there are about 12 to 13 parameters. From that parameters, you can easily differentiate between this three modeling. Okay. Then we have seen that some scheme for the solid model, how we can represent that solid model in terms of the this modeling. So first is a constructive solid geometry. Means already in that software there is a call as a primitives. Okay, so you can just pick up directly shape of that part and you can just draw on that screen. Once you draw on that screen, they will ask to dimension for that particular part. Afterwards, you can modify the dimension as well as you can just change the material properties also. But it will be possible to within a minute and second we can create any a geometry. Okay, so this is the benefits of the CSG. Then we have seen that some Boolean operations like union means joining. If you want to join two different parts, then you can use this union operation. Same means subtract, then intersection. Okay. So we have seen that this type of the Boolean operation, then we will get a final model. So this is also one of the example of the Boolean operation. Then we have seen that the advantages, disadvantages of the CFG. Then boundary representing means we have to represent that all the boundaries with numbers. So it will be easy for the at the time of the assembly as well as the at time of the analysis. So better way to give the some number. It means give a boundary representation. So I will understand for what surfaces I want to give some forces. For what surfaces I want to give for some means you can call as the degrees of freedoms. Like this, you can easily understood for the applying the all the parameters. Okay. So advantages, disadvantages, then field decomposition, spatial occupancy, encoding, sweeping, pure primitives, application, where we can use this geometric modeling in actually design, assembly, manufacturing, graphics. There are a lot of applications for the solid modeling. So last but not least, types of the curves. There is a two types, non-parametric and parametric. Okay. So basically in that non-parametric, we have to go for the explicit and implicit, and parametric for we can go for the coordinates only. So we have seen for the synthetic curve in that two important points like control point and flexibility. Okay. So in that B-spline and Bezier, then cubics. So in that B-spline is a better curve rather than Bezier and Hermannite. Okay, so that B-spline curve which is having a better control over the curve. So, but after that B-spline, there is one more curve that is a nudge. That is a non-uniform rational B-spline. That is a modification of the B-spline curve which will give all the benefits over the B-spline. Okay, so nowadays, I think all of the system they are using this new curve type. There is a nubs. So we have seen that some objective question also. So these are the some questions we have taken quiz also. So this is about the review about the second chapter. So we will see a review about the next chapter number 3. So in that FEM chapter, we have seen that means chapter name itself indicates that the finite element method means we are going to do some formulate some method to calculate the all the objectives of our designer. Means if I want to calculate the stress value at a particular point at a particular element, so you can calculate the value with the help of this FEM. So basically there are 4 to 5 main points. Means types of the analysis, what are the terms, what are the types of elements, then general states, then structural and a thermal analysis for only one dimensional bar element, and latest FEM software. So types of analysis, we have seen this near about 10 type of analysis. Then we have seen that the types of the element also. So one dimensional, two dimensional. Before that, we have seen that the important terms. Okay, domain, degrees of freedom, nodes, elements, mesh, boundary condition, pre-processing, processing, and post-processing. Okay. Then we have seen that the types of the elements, one-dimensional, two-dimensional, three-dimensional. For one-dimensional, what are the element shape? What is the element size? What are the application for one-dimensional, two-dimensional, three-dimensional? Okay, like this, we have seen that three types of the element, and fourth one is other. In that mass, dampere, and spin, we can calculate the this type of the analysis into this fourth type. Then we have seen that general step, that is important point in this FEM. You can go for any analysis in any manufacturing industry. You have to do these 3 steps. Okay, compulsory. You have to do first pre-processing, then processing, and post-processing. So in that pre-processing, there are 3 important points: creation of model, discretization, then applying the conditions. Then second, solve. Third is viewing the result. So these are the some important points, important processing steps in FEM. you can just go any analysis industry, you can go any manufacturing industry. There is a design department and analysis department. In that analysis department, they have to design and analysis department. They have to do these three steps. Okay. The next slide is structural analysis of the one-dimensional bar element. For that, we have to create one stiffness matrix formula. Okay, that is the AE by L into 1 minus 1 minus 1 1. Okay, this is the stiffness matrix, and only stiffness means AE by L. This is the difference. In last quiz also, I asked one question. Which one is the stiffness? Means AE by L is represented option stiffness, option B stiffness matrix, option C none, option C both. Like this way I have asked one question. So answer is for AE by L is only stiffness. We can calculate only stiffness. Okay. But AE by L into 1 minus 1 minus 1 1, that is nothing but your stiffness matrix. Okay. Please remember the difference between the matrix and simple stiffness. Then we have seen that how to calculate the stiffness matrix for the particular element, that is a K1, K2, K3. Then how to make a global matrix, that is a K is equal to K1 plus K2 plus K3. Means at the time of the addition from the first element stiffness matrix, that is K1, that is the last element of the first element which is added to first element of the second stiffness matrix, then last element of the second stiffness matrix which is added into first element of the third matrix. Like this we have to go for the global matrix addition. After that we have seen that the thermal analysis of the one-dimensional bar element. In that we have formulated the stiffness matrix formula with help of our previous structural analysis. We have create the formula like means K into T is equal to Q. K here K is a thermal conductivity matrix in terms of the thermal analysis. Capital T is a temperature and capital Q is a heat flow rate. Okay. So in terms of the thermal analysis, we are going to replace that K in terms of the thermal conductivity matrix. Okay. And in structural, there is K stands for the stiffness matrix. Okay. Like this, in this we have to calculate the intermediate temperature as well as the heat flow. The last point of this chapter, we have seen that the latest FEM software. So there is a list of the FEM software. So we can go through this. This is the division about the third chapter, FEM. So and last we have seen that the automation. So basically in that automation, we have seen that the revolution and the important concept of the automation means what is meant by automation, what are the types of the automation. Okay, basically three types: fixed automation, programmable, flexible. Then we have seen that some advantages of the automation and disadvantages. Okay, so how we increase the productivity, how we will get the better benefit as compared to other industry. We have more competitors, so we have to produce product with less price and good quality. So for that we have to reduce lead time, we have to reduce cost of that product. So for that we have to use some techniques, modern techniques. So group technology is nothing but one of the modern techniques. Then in that we have seen some part family, how to make then classification, codification. Okay. So by using Opti system, we have done one of the best practice in our industry. Then we have seen machine cell design with a different mechanism. Then we have seen some Opti system example. Then we have seen some important concepts like CAPP. Before going to manufacturing, we have to do some process planning in terms of the manufacturing operation, sequence of operation. CAPP is nothing but one of the simple bridge between the CAD phase and manufacturing phase. So for there, some characteristics is important. Before going to applying the CAPP into manufacturing, that CAPP must understood the part features, machine tool knowledge, and the calculating multiple capacity. Okay. So in in that CAPP there are two important points: variant and retrieval. Variant and generative. In that variant, we can use existing file for the processing new files, but in that generative, we have to start from the origin itself. We have to go for the all the planning process from the start phase. So this is the basic difference. So variant, we can use existing data for creating new one. Last one is generative. Then computer integrated manufacturing means we are going to make a concurrent engineering department for making the all the process is a living thing. Means flexibly we can just make a product within less time. We can reduce lead time. We can increase the productivity and we can increase the quality as well as. Okay. So there are some elements, benefits of the same. For that same, we have to go for the some standard method that is an MRP. So by using this MRP, we can reduce inventory cost. Okay. So then by using ERP, we can make a better business flow of that our system. So it will be manage the product cost. It will be manage service delivery, payment, and feedback from customer. And last but not least, that is a rapid prototyping. So what are the importance of the rapid prototyping in our manufacturing industry? And there are some methods to make a product without doing any assembly. Only one step we can produce a one prototype for representing that part in front of the market. Okay, as earlier possible. Okay. नाहीतर असं होतं की आपल्या डोक्यामध्ये काय आयडिया असते आणि आपली आयडिया ऍक्च्युअल पार्ट मध्ये कन्वर्ट होण्या अगोदर दुसरं कोणतरी ती आयडिया मार्केटमध्ये लॉन्च करतो. मग हे गोष्टी टाळण्यासाठी आपण काय करतो, एखाद्या गोष्टीसाठी पेटंट फाईल करतो जेणेकरून आपली आयडिया कोणी चोरू नये. सेकंड थिंग, लवकरात लवकर मार्केटमध्ये ते प्रोडक्ट आपण लॉन्च करण्या अगोदर की मार्केटला सांगू की आम्ही असं असं प्रोडक्ट लॉन्च करणार आहोत. ठीक आहे, त्याच्यासाठी आपल्याला एक प्रोटोटाइपची गरज असते. म्हणजे ऍक्च्युअल प्रोडक्ट न करता एक छोटं प्रोटोटाइप करायचं आणि मार्केटमध्ये लॉन्च करायचं की बाबा हा आमचा पार्ट असा असू शकतो, असा होणार आहे. ठीक आहे, तुम्ही जर आपला ऑटोमोबाईल इंडस्ट्रीचं एक्झाम्पल घेतलं तर दिल्लीमध्ये प्रत्येक वर्षी जानेवारी ते फेब्रुवारी मंथमध्ये एक ऑटो एक्सपो म्हणून नावाचा एक खूप मोठा इव्हेंट असतो. म्हणजे त्याच्यामध्ये काय असतं, जे आपल्या ऑटोमोबाईल इंडस्ट्रीमध्ये नेक्स्ट 4 to 5 years मध्ये जे बाईक्स असतील, 4 व्हीलर कार्स असतील, जे काय असेल, जे काय 5 ते 6 वर्षांतर लॉन्च होणार आहे त्याचं प्रोटोटाइप, त्याचे मॉडेल तिथं ठेवलेले असतात. ठीक आहे, म्हणजे ॲडव्हान्स लेवलचे फूडचे जे तुम्हाला ऑटोमोबाईल्स मधले एलिमेंट्स असतील ते तुम्हाला तिथं बघायला भेटतील. जर तुम्हाला वेळ असेल, जर तुम्हाला कधी चान्स भेटला दिल्लीला जायचा तर तुम्ही ऑटो एक्सपोला नक्की विजिट द्या. तो इव्हेंट जवळपास 1 महिन्यावर असतो. ठीक आहे, तसाच सेम इव्हेंट एक पुण्यामध्ये पण असतो, ऑटो एक्सपो म्हणून असतो, पण तो एवढा जास्त मोठा नसतो, तो छोटा असतो. So if you will get the some chance to visit at Pune and Delhi, you can definitely visit that Auto Expo event. So you will understand what is a mechanical industry, okay, and automobile industry. So that time we can use this rapid prototyping. Then you can see here there are basic 3 steps in rapid prototype. First, we have to make a 3D model on computer. Then that model we have to transfer that STL format to slice layer, and that slice layer will be go for the actual manufacturing by layer. Okay. So this is the process and advantages, disadvantages. This is the content beyond syllabus. Here you can use this PLC techniques. Here we can use our sensor door at office level or in industry. Okay. So this is about the first section. So already I have taken a mega quiz on the section number first, okay, which is carried out in last lecture, but I found some of the students still not getting all the points related to this section number first. Okay, मी स्टार्टिंगला चॅप्टर वाईज क्विज घेतल्या, नंतर एक ग्रँड टेस्ट घेतली ऑल चॅप्टरची. ज्या मिस्टेक तुम्ही फर्स्ट चॅप्टरच्या क्विज मध्ये केल्या होत्या त्याच मिस्टेक तुम्ही परत अजून रिपीट तुम्ही मेगा क्विज मध्ये केल्या. I expected from all the students that time, whatever that you have made mistakes in first chapter quiz, second chapter quiz, and third chapter quiz, that you didn't do. But unfortunately, you did. Okay. So I request to all the students, please go through MCQ booklet or go through once you can just visit that our TYB study material sheet, then you can just see the MCQ and assignment booklet, so you will get some more idea about this test. Okay. So for if you're thinking like this, there is a no university exam, so why we are studying? Okay. So after 1 year, after 1.5 year, you will just get pass out. Okay. So if you have some great opportunity in your hand in terms of the job, so you have to uh, have some knowledge about the mechanical. Okay. So for that purpose, please be serious and be sincere. Attend sincere lecture and do some study. After the lecture, go through that study material sheet. Just visit that all the materials. Okay. So I will just take attendance one more time. So I request to all the students, present students, within 1 minute, write your roll number in chat box. Fast. Okay. So we'll start a second section of the CAD MCQ. So basically, in second section, if you look into our second section of the CAD-CAM, so in that second section, we will see numerical control machines, means how the advanced level machines are doing manufacturing by using CAD-CAM system. Then, what are the basic tools required for the CAD-CAM system in automation? The next, last but not least, that is a very important chapter in our CAD-CAM system. That is a manual part programming. So, in that chapter, how to make a part program? Okay, for that part program, we are using G code and EM code. Okay, that is a G means preparatory code and M means miscellaneous code. Okay, so there is a near about 100 G code and 100 M code, but there is no need to recall or remember all that 200 code for making any simple program. So from my knowledge, we have to just remember only near about 20 G code and 20 M code. If you remember that 40 G and M code, you can write simple programming as well as middle level programming. Okay, not any hard level, but you can make any program by using this 40 code also. So you have to just remember 40, total 40, that is a 20 G code and 20 M code. Okay. So after that, we will see some drilling, milling, turning programming. for that particular manufacturing of the part. Okay. At the time of the university question, they are giving one simple drawing. Okay. And they are giving one sheet, and in that sheet there is only consist like material and material quantity, and they are asking just to make a CNC part programming for this particular operation. They are giving some milling, drilling, or boring, whatever that operation is there. We have to do a part program, and this question will ask for the 8 marks. You can just forget about the university exam, but in our mechanical engineering, once you look out the our automation system, so each and every operation there is a need of the a part program, like CNC VMC machine operator. They have to put the part program for that particular manufacturing. So you can just understand uh, what is the importance of the part programming. Okay, once you able to do a part program in terms of the that particular manufacturing product, then you will be the master in terms of the mechanical engineering. Okay, so I request to all of you in our second section, last chapter, manual part programming. That is a very important chapter. So as per your my knowledge, if you want to gain some knowledge in terms of the programming, in terms of the CNC VNC machine operating, so you have to just keep attention on that chapter. Okay, and chapter number 4 and 5, that is a basic information regarding that advanced levels machine means what are the numerical control machines. Okay, there are some types of the NC machines, how that NC machine was developed. Hmm? Then earlier stage we are using the higher level advanced machine. What are the advantages of that machine? Okay, so step by step we will see uh, introduction part of the NC machine. Then we will move towards the tooling purpose in CNC and VMC, which type of the toolings we are using currently, and in conventional also. Okay, means tool storage, that is a turret and turret indices, and that type of the jigs and fixtures. Okay, for placing the job on the SCNC platform. Then how that robot or how that advanced level machining doing the manufacturing we will see in detail. So we will start our second section, chapter number 4. So that is called as fundamentals of ENC system. Okay, so in this chapter we will see evaluation part of the NC, then elements of the NC manufacturing system, then what is the concept of the work zero and machine zero. So basically this is the two important point as compared to the making the part programming, work zero and machine zero. Then types of the ENC system. There are different types of the numerical control system as per the classification. Then structure of the NC system. Then what are the drives? Okay. Then steps in NC manufacturing. Then advantages and disadvantages. Then flexible manufacturing system. I thought in automation chapter we have seen that the like machine cell design there is a one point and there are 5 types. Okay, in that one point is that flexible manufacturing cell and flexible manufacturing system. Okay, in that time we have discussed what is meaning of the flexible manufacturing system and how that FMS is working. Okay, then we will see again here also. Then what are the elements, then what are the application and advantages and disadvantages. Okay. So this is the just overview syllabus about the 4th chapter, that is the fundamentals of the ENC system. Okay, so we'll start from the one by one. So ENC system is one of the systems where actions are controlled by the direct insertion of the numerical data. Okay, त्याच्यामध्ये आपण काय करतो, एनसी मशीन म्हणजे काय की थोडक्यात एक हायली ऑटोमेशन सिस्टम आहे. त्याला आपण कंट्रोल कसं करतो, तर आपण काहीतरी त्याला इनपुट देतो इन टर्म्स ऑफ द पार्ट प्रोग्राम. आपण त्याच्यामध्ये पार्ट प्रोग्राम फीड करतो आणि तो पार्ट प्रोग्राम स्टार्ट करतो. नंतरचं काम जे काय आहे ते ऑटोमॅटिक त्या पार्ट प्रोग्रामचं आहे, ते मशीन त्याच्यावरती रन होते आणि of that part program we will get a desired product. Okay, so that is the most important work of this system in our industry. Okay, so this is definition according to Electronic Industries Association. Okay, हे एक असं एक असोसिएशन आहे, असे बरेच असतात. ASM आहे, अमेरिकन स्टँडर्ड ते एक असोसिएशन आहे. तसंच हे इलेक्ट्रॉनिक इंडस्ट्री असोसिएशन आहे. त्याच्यामध्ये त्यांनी असं सांगितलं की न्यूमेरिकल कंट्रोल मशीनचं काम काय की डायरेक्ट आपण त्याला काहीतरी इनपुट देतो, त्या इनपुटच्या आधारावरती ते तसं तो डेटा क्रिएट करतो. ठीक आहे, प्रोडक्ट क्रिएट करतो. ठीक, सो दिस इज द डेफिनेशन ऑफ द एनसी. देन वी विल सी सम हिस्ट्री अबाउट द एनसी. ओके, एनसी मशीन ही कोणी इन्व्हेंट केली? जॉन पर्सन फ्रॉम MIT. MIT आपण ऑलरेडी हा शब्द ऐकला असेल लास्ट चॅप्टर मध्ये. Massachusetts Institute of the Technology, okay, which is the famous for the automation. And 1949 एक US युनायटेड स्टेट्स एअरफोर्सने यांना विचारलं होतं की तुम्ही एखादी एनसी मशीन तयार करता का. ठीक आहे, त्यावेळेस त्यांनी फक्त विचारलं त्यांच्या एअरफोर्ससाठी. मग हे MIT इन्स्टिट्यूटने काय केलं, 1952 मध्ये एक छोटं प्रोटोटाईप एनसी मशीनचं डेमॉन्स्ट्रेशन घेतलं with the help of the punch tape input. म्हणजे पार्ट प्रोग्राम असा इनपुट दिला नाहीये. पार्ट प्रोग्राम हा आताच्या लेटेस्ट काळामधला आपल्याला इनपुट आहे. म्हणजे डायरेक्ट आपण इन टर्म्स ऑफ द सॉफ्टवेअर वी कॅन क्रिएट अ प्रोग्राम विथ द हेल्प ऑफ द USB वी कॅन गिव्ह एज इनपुट. बट at that time that facility was not there. So that type they are using punch tape input. Punch tape means असं काहीतरी आपले पहिले कॅसेट असायचं बघा, जुने कॅसेट. आपण ते तोडायचो, ते आपले रील बाहेर काढायचो, खेळायचो, बाहेर वाऱ्यावरती उडवायचो, माहितीये का. त्याच टाईप मध्ये त्याला एक पंच टेप असे मोठं लेवल असे जाड असतं आणि त्याची विड्थ पण जास्त असते. ते आपण त्या मशीनला प्रोव्हाइड करायचो. त्याच्यामध्ये ते डिजिटल कोडिंग मध्ये प्रोग्राम फिक्स असायचा. ओके, सो त्याच्याद्वारे आपण प्रोडक्शन करायचो. मग त्याचा तोटा काय होता की सपोज आपला प्रोग्राम बदलायचा असेल तर आपल्याला नवीन पंच टेप रीडर बनवायला लागायचे. म्हणजे ते पंच टेप रीडर एका पार्टसाठी ते फिक्स असायचं. ठीक आहे, तसं अलीकडे नाहीये. प्रोग्रामिंग मध्ये कसं आहे, सपोज ऑलरेडी आय हॅव मेड वन प्रोग्राम. ओके, अँड आय वॉन्ट टू चेंज सम डिझाईन ऑफ दॅट प्रोडक्ट. सो in that program only I will make small changes and then I will provide that program to that machine. Okay, so that will also produce a new product. Okay, so like this that time they have made some prototype. Then 1959 that announced that automatic program tools, a programming language will be imported in that machine. Okay, जे काय प्रोग्रामचे टूल्स असतात जे ऑटोमॅटिक जनरेट करतात लँग्वेज, ते पण त्यांनी जनरेट केले. नंतर त्यांनी काय केलं 1960 मध्ये direct numerical control eliminated the paper tape punch programs. म्हणजे 1960 मध्ये त्यांनी पंच टेप, अगोदर काय होतं 1952 मध्ये फक्त त्या मशीन पंच टेप रीडर वरती चालवत होत्या. ठीक आहे, 1960 मध्ये त्यांनी अशी एक DNC मशीन तयार केली की ज्याला पेपर टेप पंचची गरज नाहीये. ओके, अँड अलाउज द प्रोग्रामर्स टू सेंड फाइल्स डायरेक्टली टू मशीन. म्हणजे नंतर त्यांनी अशी मशीन डेव्हलप केली की त्याला पंच टेप रीडरची गरज नाही. डायरेक्ट जो तुम्ही प्रोग्राम जी कोड आणि एनकोड यूज केलेला आहे, तयार केलेला आहे, तो प्रोग्राम तुम्ही डायरेक्ट मशीनला प्रोव्हाइड करू शकता. ओके, the next in 1970 CNC machine tools and distributed that is a direct numerical control machine was developed. Then 1980 graphics based CAM system introduced. ओके, जे आपण फर्स्ट चॅप्टर मध्ये बघितलं. मी आज मुद्दाम फर्स्ट सेक्शनची रिव्ह्यू काय घेतली, ह्या चॅप्टर मध्ये एनसी इंट्रोडक्शन फंडामेंटल्स मध्ये जे काय आपण फर्स्ट सेक्शन मध्ये शिकलेल्या सगळ्या गोष्टी आहेत त्या इथे येणार आहेत. तर ग्राफिक्स स्टँडर्ड सिस्टम मध्ये आपण बघितलं की ग्राफिक्स स्टँडर्ड असण्यासाठी काय काय लागतं, टेक्स्ट, पिक्चर पोर्टेबिलिटी, प्रोग्राम पोर्टेबिलिटी, जे काही ते कॅम्प सिस्टम मध्ये जे ऍक्च्युअली प्रोग्राम प्रोसेस सिक्वेन्स तयार करत असतात त्यावेळेस लागणाऱ्या गोष्टी आहेत त्या सगळ्या 1980 मध्ये त्यांनी इंट्रोड्यूस केल्या. ठीक आहे, फॉर मेकिंग द जिओमेट्रिकल मॉडेल. Then 1990 प्राइस ड्रॉप इन सीएनसी टेक्नॉलॉजी. पूर्वीच्या काळामध्ये कसं होतं की एक सीएनसी मशीन घ्यायची म्हटलं इंडस्ट्रीला तरी खूप म्हणजे कॉस्ट असायची. ठीक आहे, नंतर नंतर जशी जशी डेव्हलपमेंट होत गेली तसं तसे थोड्या मशीनच्या प्राइस कमी होत गेल्या. ठीक आहे. देन 1997 पीसी विंडोज बेस्ड ऑन द सीएनसी सिस्टम्स इंट्रोड्यूस. म्हणजे पहिलं कसं होतं जे काही सीएनसी मशीन आहे त्याच्यावरती छोटीशी स्क्रीन होती, तुम्ही त्याच्यावरतीच ऑपरेट करू शकत होता आणि करावं लागायचं. पण आता नंतर काय झालं 1997 नंतर त्यांनी एक सेपरेट पीसी आपण म्हणजे पीसी वरती सगळं करू शकतो आणि त्याचं डायरेक्ट इनपुट मशीनला जोडायचं. तुम्हाला मशीनवरती काय करायची गरज नाही, ते पीसी वरती इनपुट द्यायचं मशीनमध्ये ऑटोमॅटिक तुम्हाला तिकडे आउटपुट भेटेल. ठीक आहे. देन 2009 onwards विंडोज 7 यूज फॉर द फर्दर प्रोसेस. ओके, आता सगळ्यांनाच माहिती आहे विंडोज 7 नंतर परत भरपूर विंडोज 8 आहे, विंडोज 10 आहे, अपडेट्स येत गेले, सिस्टम अपग्रेड होत गेली. ओके, लाईक दिस इंडस्ट्री अडॉप्टेड लेटेस्ट अपडेट्स. सो वी हॅव टू ऑल्सो अडॉप्ट latest technology for in even your daily life routine also and your academic also. Okay, unless and until you will not improve yourself. Okay, so this is just a general evaluation of the numerical control machine. So now you can see in that Massachusetts Institute of Technology was developed the first ENC machine. You can just imagine the size of that machine. One man is standing in that side, left side. Okay, so you can just imagine the size of the ENC machine even than the greater than the one of the just you can call it like one compartment. Okay, so one side the placing of the all the machine panels, one side actual machine tools. Okay, so that will acquire a large floor place and it will require a space also and design of that machine is large. Okay, म्हणजे पूर्वीच्या काळामध्ये मशीन जी काही पहिली मशीन तयार केली एमआयटी ना, ठीक आहे, एनसी मशीन त्याची तुम्ही साईज बघा आणि आताच्या तुम्ही एनसी मशीन बघा त्याची साईज बघा. म्हणजे किती प्रमाणात त्यांनी मॉडिफिकेशन करून अपडेट करून नवीन सिस्टीम ॲडॉप्ट करून मशीनची साईज पण कमी केली आणि त्याचे ऍप्लिकेशन पण वाढवलेत. ठीक आहे, तसे त्याचे ॲडव्हान्टेजेस पण खूप आहेत. आणि तसं बघायला गेलं तर सुरुवातीच्या मशीन हे जे होतं त्याची कॉस्ट पण खूप होती आणि आताच्या बऱ्यापैकी त्याच्यासाठी आता पण कॉस्ट खूपच आहे, पण ॲज कम्पेअर्ड त्याच्या ऍप्लिकेशन अँड ॲडव्हान्टेजेस त्या दृष्टिकोनातून त्यांनी प्राइस ड्रॉप केले होते. Then what is the numerical control of the machine tool? How that NC machine will control the all the machine tools. Okay, so it is just one of the method of automation in which various functions of the machine tools are controlled by the numbers, letters and symbols. म्हणजे तुम्हाला जर बघायला गेलं तर तुम्ही जर आपल्या वर्कशॉप मध्ये सीएनसी आणि व्हीएनसी मशीन बघितली असेल आणि ॲज वेल एज ऑलरेडी यू हॅव वर्कड ऑन द लेथ मशीन्स. ओके, या सर.
Yes, sir.
हॅलो, सगळं व्यवस्थित ऐकू येते ना?
Ha, yes, sir.
Hello. Okay, so I will just ask you one question. Yes, sir.
Yes, sir.
Hello.
Yes, sir, you are
already
audible.
you have worked on the lathe machine. Okay, in second year. No, audible. I am asking you one question
Yes, sir.
to you. Okay, so just give me one answer. Already you have worked on the lathe machine in second year, second semester workshop practice. Okay.
Yes, sir.
So for that lathe machine, there is any tool storage unit is there?
No, sir.
Or any sequence is given for the tool, means tool number 1, tool number 2, tool number 3, like this, anything is there?
No, sir.
Okay, So good. So for that conventional manufacturing means lathe machine, that previous machines, for that there is no any tool storage as well as any not a nomenclature for that tool. Okay, but you can just see in the CNC and VNC machine there is a tool turret and tool indices is there. So in our workshop machine, CNC machine, in that tool turret, you can store the number of the tools, and for the tools, you can give the number that is a T01, T02, T03 like this. Means T01 belongs to the drilling, whatever that you have make a programming. Okay, in that programming, you have already mentioned that the tool number one is for drilling purpose, tool number two for the whatever that operation is required for that part. So like this, whatever that machine tool is there on the that turret. So for that tool, we have to just call that tool to for that particular operation. For that purpose, we are using this numerical control machines. So I will explain in more details with next point or next chapter, that is a chapter number 8, means part programming, how we are going to use this type of the tooling nomenclature in details. Okay, so now you can just see here in that image, this is actually elements of the NC machine tool operation. So first image at left side corner top side, you can see there is a one actual drawing of the part program. Means त्याच्यामध्ये ड्रिलिंग आहे, त्याच्यामध्ये सगळ्या डिटेल्स आहेत, डायमेन्शन आहे, त्याच्यामध्ये तुम्हाला सगळे डिटेल्स दिले. जसं आपलं एमडीआर मध्ये मशीन ड्रॉइंग मध्ये असेंबली अँड डिटेल्स मध्ये कसं एखाद्या पार्टचे डिटेल्स असायच्या सगळ्या इन टर्म्स ऑफ द डायमेन्शन ॲज वेल ॲज द पॉईंट्स. ओके, सो ते मला ड्रॉइंग करायचं आहे, त्याच्यासाठी मला काय करावं लागतं, पहिल्यांदा पार्ट प्रोग्राम करायला लागतो. मग पहिली स्टेप काय, हे बघा पार्ट प्रोग्राम के M030 G00X34.43Y12.5. दिस इज द एक्झाम्पल आहे, तुम्ही सिरियस घेऊ नका, फक्त एक्झाम्पल आहे पार्ट प्रोग्रामचं. तो काय स्टार्ट पण म्हणजे वरती डॅश डॅश केले, खाली डॅश डॅश केले, म्हणजे स्टार्टिंगच्या लाईन मिसिंग आहेत, एंडच्या लाईन मिसिंग आहेत. मी तुम्हाला चॅप्टर नंबर 8च्या वेळेस सांगतो. ठीक आहे, तर ह्याच्यामध्ये बघा तो पार्ट प्रोग्राम केलाय. ठीक आहे, त्याच्यानंतर त्या पार्ट प्रोग्रामचं प्रोग्राम टेप मध्ये कन्वर्ट केलंय. ठीक, म्हणजे जे पंच रीडर होतं पहिले जुनं, म्हणजे आपण डायरेक्ट प्रोग्राम इम्पोर्ट करू शकत नव्हतो सिस्टीम मध्ये, त्याच्याऐवजी ते पंच टेप होते. त्या पंच टेप अशा असतात, त्या पंच टेप रीडर मध्ये जातात आणि तिथून परत कम्प्युटर सिस्टीम मध्ये ओके कंट्रोल म्हणजे एनसी कंट्रोल मध्ये, तिथून ऍक्च्युअली त्या तुमच्या मशीन वरती मग ते जसं ते सिग्नल देईल त्या पार्ट प्रोग्राम मधून तसं तिकडे ते मॅन्युफॅक्चरिंग करणार. ठीक आहे, so this is the basic elements of the NC machine tool operation system. Here we have to do some part programming, we have to convert that part program into program tape, and that program tape we have to transfer that the tape reader. Okay, and accordingly machine to the actual manufacturing. So this is the basic elements. Then now you can see next slide is the elements of the NC manufacturing system. So these are the three major elements. First is a part program, second is a machine control unit, okay, and last one is a processing equipment. Okay, so basic you can just make some sense in programming. We have to do programming, then machine control unit. Whatever that we have made that program, we have to do one operation like give as the input to that machine, and whatever that data processing and controlling of that data, that thing happens in this second step, and last is actual manufacturing step, that is called as processing equipment. So these are the three important elements of the manufacturing system. Okay, next, so whatever that three steps in that program of the instruction, that part program actual in that machining. Okay, means whatever that we have made a part program for that machining operation, we have to provide the part program. Then actual in machine control means only controlling processing is there. There is no any creation, there is no any addition, only controlling, and last only performing means only manufacturing. These are the major three elements. First, that is a part program. Okay, part program is nothing but it is a set of statement. म्हणजे जे तुम्हाला ड्रॉइंग दिले तुमच्या समोर की हे असंच मला ड्रॉइंग मॅन्युफॅक्चरिंग करायचं आहे. ते ड्रॉइंग बघून तुम्ही जे काय सेट ऑफ स्टेटमेंट्स म्हणजे इन टर्म्स ऑफ द प्रोग्राम मीन्स जी कोड मेन कोड तुम्हाला काहीतरी प्रोग्राम लिहायचा आहे. आणि एकदा तुम्ही तो प्रोग्राम लिहिला की तो जो काय सॉफ्ट कॉपी मध्ये जो काय तुमचा प्रोग्राम आहे त्याचं कन्व्हर्जन तुम्ही सिग्नल मध्ये करता. ओके, आणि ते सिग्नल्स कुठे जातात स्पिंडल आणि ड्राईव्हला. ठीक आहे, म्हणजे तुमची काही मोटर असेल स्टेटर मोटर असेल ओके त्याला ते सिग्नल जातात आणि ते सिग्नल गेले की ती मशीन तशी ऑपरेट होते आणि तुमचं ते ऑपरेशन परफॉर्म होतं. ठीक आहे, तर हा पार्ट प्रोग्रामचा रूल आहे. तर इट इज वन ऑफ द इनपुट डिव्हाइस mechanism for part program to be entered into NC control machine, and the most commonly used input devices as keyboards, punch tape reader, and a coded instruction means जे काही आपण प्रोग्राम करतोय एक इनपुटच टाईप आहे त्या मशीनसाठी. मग ते कसं कसं देऊ शकता तुम्ही कीबोर्ड मध्ये. म्हणजे प्रोग्राम तुमच्या पीसी वरती आहे तुम्ही कीबोर्डद्वारे काहीतरी एंटर करा जे काय व्हॅल्यू असेल रिक्वायर्ड तिकडे लगेच मॅन्युफॅक्चरिंग होणार त्या टाईप मध्ये. ठीक आहे, पण स्टेप रीडर जसं मी म्हटलं की स्वतः डायरेक्ट मशीन टू मशीन प्रोग्राम टू मशीन जे कनेक्शन होतं त्याच्या अगोदर पंच स्टेप रीडर यूज करत होते. तुम्ही ते करू शकता. ठीक आहे, सो दिस इज द वन ऑफ द इनपुट टाईप ऑफ द एनसी मशीन. So it is the series of the coded instruction required to produce a part. It controls the movement of the machine and control auxiliary functions. Sorry. So basically, part program perform all the means operating the machine tools, operating the machines, operating the program, operating all the such rotations, coolant operations, and whatever that manufacturing operations. So basically, that coded instruction as composed by using letters, numbers, and symbols. Okay. So आता पार्ट प्रोग्राम कसा लिहायचा त्याचा एक बेसिक स्टेप दिला. हे बघा की लेटर यूज करून नंबर आणि सिम्बॉल. ओके, सो तुम्ही खाली एक स्टेटमेंट बघा, खाली एक एक्झाम्पल दिलंय काय N10 G01 X5.0 Y2.5 F15.0. ह्याच्यातलं N10 काय आहे ही एक सिक्वेन्स नंबर आहे. म्हणजे तुम्ही जे काही ऑपरेशन करणार आहे त्या लाईनचा नंबर आहे N10. यू कॅन स्टार्ट फ्रॉम द N05 also N1 N2 N3 like this. Okay, so this is only sequence number. You can call it as just N10 means whatever that line is there in that line, whatever that operation is there, that operation will be done on that machine. Okay, G01 that is a preparatory code. G code basically G01 is the only linear interpolation mode. म्हणजे tool फक्त linear manner ने move होणार. ठीक आहे, X5.0 म्हणजे तो टूल X कोऑर्डिनेटला 5 वरती जाऊन थांबणार. Y2.5 म्हणजे Y कोऑर्डिनेटला 2.5 आणि F15.0 मीन्स त्या टूलचा फीड रेट हा 15 इंच पर मिनिट असेल. ठीक आहे, एक एक्झाम्पल आहे लाईनचं. त्यावेळेस ऍक्च्युली आपण पार्ट प्रोग्रामचे जे काही चॅप्टर आहे लास्ट मॅन्युअल पार्ट प्रोग्रामिंग त्याच्यामध्ये तुम्हाला डिटेल मिळेल. ठीक आहे, नेक्स्ट प्रोग्राम इनपुट डिव्हाइस. ओके, सो ऑलरेडी जसं की मी मगाशी सांगितलं की प्रोग्राम पार्ट प्रोग्राम ॲज आपण इनपुट डिव्हाइस म्हणून बघतो तसंच त्याच्यामध्ये प्रिव्हियसली ते पंच स्टेप रीडर यूज करत होते. एकदा का त्यांनी नवीन सिस्टम इन्व्हेंट केली की ज्याच्यामध्ये त्यांनी काय केलं डायरेक्ट तो प्रोग्राम आपण कम्प्युटरला प्रोव्हाइड करू शकतो. त्यावेळेस आपण डायरेक्ट जे काय प्रोग्राम केलं ते डायरेक्ट आपण मशीनला प्रोव्हाइड करतो. सो दिस इज द बेसिकली इनपुट डिव्हाइस मेकॅनिझम for creating the manufacturing, and one of the most important input device that is punch tape reader. Okay, so now you can just see here whatever I was talking about that punch card. So punch card, like this type of the punch card is there. So this is the actual paper type. So whatever that program we have converted into that punch type, and punch card will be provided to that reader, and reader will be passes that signal to the actual machine. Okay. So this is actually punch tape reader. Whatever that machine is there, that person is doing the typing that program into that punch punch card, and whatever that program once you type on that punch card will be provided to that machine. Okay, so that machine will be read that punch tape signal and passes that signal to the spindle. So punch tape is one of the sequence of the process steps is called as the part program. So medium to write a part program in NC machine was a 1-inch punch tape. त्यावेळेस ही साईज होती. NC machine coding system uses alphabetically characteristics, numerical and other special symbols. Okay. आपण पार्ट प्रोग्राम मध्ये नंबर्स यूज करू शकतो, अल्फाबेटिकल आणि बाकीचे जे काही सिम्बॉल्स असतील, पर्सेंटेजचे असतील, तो दुसरे कुठले. ठीक आहे. तर हे एक्झाम्पल आहेत पंच टेप रीडरचे. बघा, पंच टेपचे एक्झाम्पल हे असे पंच टेप असतात. ठीक आहे. हे आपण फक्त ते कॅसेट कसं प्रोव्हाइड करतो, दुसऱ्या मशीनला प्रोव्हाइड करतो, ते रीड करत करत ते ऑपरेशन पुढे कॅरी होत होते. इथे पंच टेपचं सगळं बायनरी ऑपरेशन वगैरे सगळं ते डिजिट्स चॅनल्स आहेत. त्याच्यामध्ये काय आपल्याला डिटेल्स मध्ये जायचं नाही. त्याचं फक्त डिस्क्रिप्शन दिलं की ते पंच टेपचं रीडिंग कसं होतं ते. ठीक आहे. हे पंच टेप रीडर एकदा कधी पंच टेप ह्याला प्रोव्हाइड केली की ते टेप त्याच्या भोवती फिरते, त्याचे इन्स्ट्रक्शन कोडेड करून ते सिग्नल मधून मशीन जातात. हे नवीन टाइप ऑफ द फानुक सिस्टमचं पंच टेप रीडर. Fanuc is one of the system where they have developed some GMT code. Okay. So this is the first elements of the NC system, that is the part program, and second one is the machine control unit. So basically it is the heart of the NC system. जे काही आपली NC system आहे throughout, त्याचा important part म्हणजे machine control unit. जे काय सगळं कंट्रोलिंग प्रोसेसिंग आहे ते सगळं त्या सेकंड एलिमेंट्स मध्ये होतं. म्हणजे काय होतं की दिलेलं जे काही इनपुट आहे इन टर्म्स ऑफ द प्रोग्राम ॲज वेल ॲज अ पंच टेप, ते काय करतं, ते जे काही कोड आहेत ते रीड करून इन्स्ट्रक्शन देतं वन बाय वन. त्या इन्स्ट्रक्शन डिकोड करतं. ओके. म्हणजे ते त्या मशीनला कळणाऱ्या लँग्वेज मध्ये डिकोड करतं, आणि जे काही डिकोड केलेली इन्फॉर्मेशन आहे ते काय करतं, मशीनच्या ऍक्सेस मध्ये तिकडं मशीनला ऍक्च्युली प्रोव्हाइड करतं, जिथे ऍक्च्युली मशीनचं मॅन्युफॅक्चरिंग होतं. आणि लास्ट कंट्रोल मशीन टूल ऑपरेशन, जे काही ऑपरेशन्स आहेत ते कंट्रोल करतं तिथं मशीन कंट्रोल युनिट मध्ये. ठीक आहे. म्हणजे तुमचा पहिला पार्टचा एलिमेंट होता पार्ट प्रोग्रामिंग, तो ऍज अ इनपुट डिव्हाइस वर्क करतोय. तो काय एकदा तुमच्या मशीन कंट्रोल मध्ये आला, मशीन कंट्रोल सगळ्या गोष्टीला कंट्रोल करतं, कोडिंगचं डिकोडिंग करतं, डिकोडिंगच्या इन्स्ट्रक्शन परत ते पुढे मशीनला पाठवतं आणि सगळे मशीन टूलचे ऑपरेशन कंट्रोल करतं. सो इट इज द मोस्ट इम्पॉर्टंट एलिमेंट्स इन द एनसी सिस्टम. सो व्हाय they are calling as a heart of the NC system. Okay. Now you can see here the types of the MCU, that is a machine control unit, that is a two. First is a data processing, second is control loop unit. म्हणजे डेटा प्रोसेस आणि लूप कसं कंट्रोल करायचं तर ते या मशीन कंट्रोल युनिट मध्ये इम्पॉर्टंट काम आहे. एकदा काही झालं की ते पुढे परत सिग्नल कुठं पास करतं, प्रोसेसिंग इक्विपमेंट कडे, म्हणजे जे ऍक्च्युअली आपली मशीन वर्क होणार आहे तिथं. So in that DPU, that is a data processing unit, it reads the part program, coded, decoded, process information and passes to the controller. म्हणजे अशी ओव्हरव्ह्यू सांगितला, त्याच्यामध्ये फक्त सेपरेट करून सांगितलं की जे काही इन्स्ट्रक्शन येतात कोडिंगच्या डिकोडिंग मध्ये होतं ते कुठं होतं, पहिला डेटा प्रोसेसिंग मध्ये होतं. आणि एकदा का ती इन्फॉर्मेशन पुढे लूप कंट्रोलला पाठवली की ते काय करतं, त्याच्या सिग्नल्स तयार करून ड्राईव्ह मेकॅनिझमला सेंड करतं. आणि जर त्याच्यामध्ये काय प्रॉब्लेम असेल तर क्लोज लूप मध्ये फीडबॅक मध्ये त्याच्यामध्ये परत रिटर्न माहिती येते कंट्रोल लूप मध्ये, मशीन कंट्रोल युनिट मध्ये. मग त्याच्यामध्ये काय चेंजेस होतात, म्हणजे एरर आले तर सिग्नल मशीनच्या डिस्प्लेवरती, मग ते आपण प्रोग्राम मध्ये चेंज करायच्या एकदा का चेंज केलं की परत ते रुटीन चालू. ठीक. सो फॉर डेटा प्रोसेसिंग युनिट, input devices as a punch tape reader, reading circuits, checking logics, decoding circuits, decoding करायसाठी circuit हवेत, then interpolates which supplies velocity, then सक्सेसिव्ह पॉईंट टेकिंग फ्रॉम म्हणजे जे काही तुम्ही ड्रॉइंग त्याला सप्लाय करणार आहेत त्याच्यामध्ये जे काही असे पॉईंट वाईज असतील ड्रॉइंग, म्हणजे ड्रॉइंग का तुम्ही एकदमच सगळे मॅनिफेस्टेशन नाही करणार, त्याच्यामध्ये स्टेप्स असतील, तर त्या सगळ्या इंटरप्रेट करता यावे अशी त्याच्यामध्ये सिस्टीम पाहिजे, कमांड्स पाहिजे. सो दिस इज द रिक्वायरमेंट फ्रॉम द डीपीयू. देन सीएलयू मीन्स त्याला पोझिशन कंट्रोल लूप्स पाहिजे सगळ्या ऍक्सेसला, वेलोसिटी कंट्रोल लूप्स पाहिजे, कळलं पाहिजे की कुठला तो टूल किती वेगाने ते दुसऱ्या पॉईंटला चाललाय. ऑक्झिलरी फंक्शन कंट्रोल पाहिजे, म्हणजे कुलंट ऑफ ऑन आणि स्पिंडल ऑन ऑफ करते त्याचे ऑपरेशन पाहिजे. ओके. सो दिस इज द specific requirement from the data processing and data control loop unit. Okay. So third important element of this numerical control machine, that is a processing equipment, means direct your manufacturing steps. Okay. So here only we have to do only press the button on the start the program, so then automatically that our desired product will be finalized. Okay. So this is the last step here. We are going to done actual manufacturing. So this is about our numerical control machine elements. Okay. So next point, that is the work 0 point and machine 0 point. Work 0 point कशाला म्हणायचं आणि मशीन 0 point कशाला म्हणायचं, ही एकदम म्हणजे इम्पॉर्टंट कन्सेप्ट आहे. ज्यावेळेस तुम्ही पार्ट प्रोग्राम करता त्यावेळेस तुम्हाला ह्या कन्सेप्टचा रेफरन्स घ्यावा लागतो. ठीक आहे. तर वर्क 0 म्हणजे काय, तर इट इज लोकेशन फ्रॉम विच प्रोग्राम स्टार्ट्स और ऑपरेशन स्टार्ट. म्हणजे समजा एक रॉ मटेरियल माझं एक पार्ट आहे x00 लोकेशनला, म्हणजे x0y0. ठीक आहे. आणि माझा टूल मी डायरेक्ट त्या वर्क पीसच्या टच न करता एक प्रिकॉशन सेफ्टी म्हणून मी थोड्या अंतरावरती बाहेर सेट करत असतो. ठीक आहे. म्हणजे काहीतरी अंतरावरती, म्हणजे सपोज मी घेतो x10y0, म्हणजे माझा रॉ मटेरियलचा वर्क पीस आहे x0y0 पाशी, म्हणजे ओरिजिनला, आणि माझा टूल आहे x10y0, म्हणजे x ऍक्सिस वरती माझा टूल आहे, आणि तो टूल x=10 पाशी आहे आणि माझा वर्क पीस x0y0 पाशी आहे. तर वर्क 0 पॉईंट कोणता, तर ज्या ठिकाणी तुमचा वर्क पीस ओरिजिनला आहे आणि त्या वर्क पीसचं डायमेन्शन सपोज म्हणजे एक्स ऍक्सिसला अलॉंग एक्स ऍक्सिसला एक्स डायरेक्शनला काहीतरी 4 पर्यंत संपते, म्हणजे त्या वर्क पीसचं लेंथ आहे काहीतरी 4, ती म्हणजे x=4 ला संपते. म्हणजे जिथं x=4 आहे ऍक्च्युअली तिथं टूल टच होणार आहे, तिथून प्रोग्राम स्टार्ट होणार आहे. तो पॉईंट म्हणजे, किंवा तुम्ही डायरेक्ट टच न करता त्याला थोड्या अंतरावरती लांब ठेवून तिथेही तुम्ही वर्क 0 पॉईंट देऊ शकता. तो पॉईंट म्हणजे वर्क 0. ठीक आहे. आणि मशीन 0 म्हणजे काय, तर तुम्ही जो टूल तो बाहेर एकदम लांब प्लेस केलाय जेणेकरून तुमचा डायरेक्ट टूल त्या वर्क पीसला टच होऊ नये, म्हणून तो जो पॉईंट असतो टूलचा तो म्हणजे मशीन 0. ठीक आहे. म्हणजे तो आपण डिफाईन करू शकतो. ठीक आहे. आणि त्याला आपण काय म्हणतो 0 पॉईंट पण म्हणू शकतो, आणि वर्क 0ला जॉब 0, फ्लोटिंग 0 म्हणू शकतो. ठीक आहे. तर हे असे कन्सेप्ट आहेत की आपण वर्क 0 कशाला म्हणायचं आणि मशीन 0 कशाला म्हणायचं. ठीक आहे. So next point. So before starting with this classification of the NC system, actually this is a very big point. The classification of the NC system means according to work and world relationship based on the motion. So for today's lecture, I think we have to stop here only. So in today's lecture we have seen that the revision about the first section, then we have started actually the second section, just fundamental part of the NC machines. Okay. So how NC machine was developed, what is the history of the NC machines, then what is the elements of the NC system as a program, machine control unit and processing equipment. So I think this is enough for today's lecture. So in next lecture we will see the next part. So I request to Yasar, please stop the recording.